Good afternoon. I am Mohammed KHAMAYSA, a researcher in the Laboratoire d'imagerie Biomédicale in the team of neural connectivity and plasticity, directed by Dr. Véronique Marchand-Bouvard. Today I will be presenting the work on the quantifying brainstem as a proxy for respiratory and bulbar function in ALS, guided and directed by the expertise of Dr. François Bkhara. ALS is a complex heterogeneous disease marked by the progressive nature of the bulbar and respiratory dysfunction. While the bulbar dysfunction is a cardinal feature of ALS, the bulbar dysfunction is complex and hard to assess compared to the skeletal muscle evaluation. And the respiratory dysfunction remains the primary cause of death in ALS patients. Therefore, our focus in the central role of brainstem and ALS for assessing the bulbar and respiratory functions, since it's linked to both bulbar and respiratory functions. Interestingly, significant alterations were detected and reported at the brainstem level, ranging from volume reduction, shape deformation, and connectivity changes. The work and the research on the brainstem level in ALS on MRI level is quite limited. Notably, the brainstem abnormality were detected even without a clinical bulbar symptom in ALS patients. And notably, the longitudinal studies demonstrated progressive brainstem atrophy over time, which make it a candidate for a biomarker in ALS for assessing respiratory and bulbar function. So last year we have published a paper on the correlation between the bulbar and respiratory function of the brainstem in the Paris cohort on a clinically trial called PULSE. I will talk a little bit about it in the next slides. Therefore, this study has two main objectives. The first one is exploring the difference between in the brainstem structure level, structures volume among ALS patients based on the phenotypes. That means where the symptom first appeared in these patients, namely bulbar, upper, and lower limb. And the second objective is to explore the correlation between the volumetric brainstem structure and the key functional outcomes of respiratory and bulbar function based for the bulbar function based on the LSFRS revised score. And for the respiratory, we have measured the spirometric measurements. And the particularity of this study is it's on a large multicentric French cohort, ALS cohort, of 202 ALS patients. This study is a part of a larger clinical trial called PULSE. PULSE aim at individualizing a predictor for ALS patients. Generously funded by the ASLA, we thank them for that, and it's organized and coordinated by the CHU de Lille under the principal investigator, Dr. David Devos. We thank them for this and his team. All the MRI data we will show here, they underwent a quality check, a quality control check in the CATI center here in the ICM. This study includes 16 different centers all over France. And for those who are interested by looking on the methodology of the PULSE study, I invite you for checking the clinicaltrial.gov under this identifier. Here I'm presenting the demographic cohort characteristic of PULSE study, of the cohort we have studied in the PULSE cohort. We included 202 patients based on the site of onset of the symptom at first. For bulbar onset ALS, where the region affected were the bulbar function, including the dysfunction of salivation, swallowing, and dysarthria. For the lower limb, they were the patient who had deficit at their legs. And for the upper limb, they were the patients with a deficit in the hand or arm function. As we see here, all the patients, they underwent a comprehensive and exhaustive neurological assessment by an expert neurologist at their center. Each patient underwent MRI scan. Here we are interested by the T1 weighted images of MRI, which is structural MRI. And all the patients underwent measurements for the spirometry. Here we employ two state-of-the-art techniques for segmentation of the brainstem. The first one via AssemblyNet, which is a logiciel or a software that uses a deep learning method for called 3D convolution network method for segmenting the brainstem. And the second method it uses a mesh atlas-based method made by an expert, by 50 experts, and via FreeSurfer for more specifically segmentation of the midbrain, pons, and medulla. Here we are looking at the comparison of the brainstem as entire brainstem, the whole brainstem in ALS patients among phenotypes, bulbar and upper and lower limb ALS phenotypes. A bulbar onset ALS exhibited significantly lower brainstem volume compared to those with lower limb and upper limb onset ALS. This pattern of significant difference between the phenotypes were consistent by both method of analysis, the AssemblyNet and the FreeSurfer. When looking at the atrophy pattern between the bulbar onset ALS and lower and upper limb onset ALS, we see the same pattern at the midbrain level and pons and medulla. Now, this slides demonstrate the correlation between the brainstem volume and the bulbar function measured by the ALSFRS-R score. We see here this significant positive correlation between the brainstem volume and the bulbar subscore is going up, which could be a clinically significant correlation. That means the higher the volume, the better the function is. These points are the mean of the values at each point of the ALS. And when we're looking at the FreeSurfer analysis, we find the same pattern of positive significant correlation between the bulbar subscore and the volumes of these regions. In this slide, I'm demonstrating one of the spirometric measurements, which the force vital capacity and supine position, which is pretty sensitive to the diaphragmatic dysfunction. I'm correlating it with the entire brainstem analyzed by the AssemblyNet. We find the same pattern of correlation where it's positive significant correlation. The higher the volume, the better the force vital capacity measurement. And when looking at the FreeSurfer analysis for more specific segmentation of the medulla, pons, and midbrain and the whole brainstem, we find the same pattern of correlation, the same positive pattern of correlation, which could be clinically significant. These findings suggest the potentials of the quantifying brainstem atrophy as a valuable marker that hold potential as a marker for assessing bulbar and respiratory function in ALS patients. And the positive correlation we have observed in this study are promising as a positive correlation. They were promising to correlate with the key functional outcomes of respiration, which could hold the potential, which highlights the brainstem critical role in disease progression. We still need a better brainstem segmentation for overcoming the challenges of the variable and complex anatomy of the brainstem, and this could be with the help of deep learning model methods that could overcome these things, and this could help also enabling the better and more precise segmentation and assessment of the brainstem structure. The need for further studies on the brainstem at this asymptomatic ALS subjects. This is very important, as Georgia has mentioned, the BREF-DMALS. We are working on this. And this could be giving and offering insights to the insights on the diagnostic application of the brainstem segmentation and quantification. And it could also offer a better understanding of the disease onset and the progression. I thank you for your attention, and I thank my team, and I would be happy to take any question regarding this research. Thank you.
Thank you. Questions? I just had a quick question. Is the difference between control, because you only showed ALS, is there a difference in brainstem volume or size between controls and, I mean, age-matched controls and ALS?
Yeah, we have looked at this. We don't see a clear difference because I think there's not many controls in the analysis. So we are working on getting more controls to achieve this objective of looking at the difference between ALS and controls.
Thank you for your talk. I have a brief question on the clinical phenotype. So as the FRS subscore does not discriminate between bulbar and pseudobulbar syndrome, and this is of utmost interest. And when you talk about brainstem atrophy, the thing is whether you have made this clinical discrimination, that's one thing. And the other thing is whether you have any information about the correlation between brainstem atrophy and NFL. And neurofilament.
Neurofilament, yeah. This is a very good question. The bulbar onset were considered as also the patient who had pseudobulbar symptoms. So the decision of considering a patient as bulbar is made by the neurologist who assessed them at first. So I suppose they had taken this in consideration. For the brainstem with the neurofilament, I think in past study, not all centers that had conducted the neurofilament assessment, but we have some centers, I think in Lille, they have conducted the neurofilament assessment, so we are looking at this.
Thank you very much.
Thank you.